Hello, good morning. Audible?
Yes, sir.
So today we'll look at these three things: the languages, grammars, and computer. So just, uh, these are the three things that are going to be underlying in the entire. Uh, so now we know the natural languages. Right? So maybe more how they operate. Right? So now, so so one thing is like in a language you have two things. One is the word, and so these words, and you also have the rules. So I mean, basically, like you have some symbols, you have some words that are defined on those symbols. Then you have some of the rules that manipulate these words to present them in some order, so that like finally they are able to communicate some ideas or facts or concepts and so on. Right? So now here, like in formal languages, so you start with finite non-empty set of symbols, and these are called as alphabets, right? So alphabet is the term that is used to denote finite and non-empty set of symbols. Right. So this alphabet is maybe it may be given by this sigma. Right. So now, given that you have these alphabets, from these alphabets you construct the next thing, which is called as string. Right? So from alphabets you construct strings. Right? So now the strings are made up of these symbols, and you can write these strings as finite sequences of symbols from the alphabet. Right? So now you have the next thing, which is the thing. Normally in an alphabet, like you use lowercase letters. So now, using these lowercase letters, you form a string. Say, for instance, like if you have an alphabet, which is it's a set of symbols. It's a non-empty set of symbols, and so you may have an alphabet as A and B. Now you may have a string, which is a sequence of symbols that is maybe AB, AB, right? So this is a string, right? So now this W is going to denote this string. I mean, it's it may be used to denote the name of this particular string. So now if you have two strings W and V, then you can perform concatenation of these two strings. Right? So you can perform concatenation of two strings which are W and so this is obtained by, say, appending these two strings. Say, for instance, if you have two strings which are from the same alphabet, so one is ABAB and say BAAB, right? So you have two strings, ABAB and BAAB. So now you can obtain the concatenation of these two strings, which is WV, which is going to be ABAB and BAA. So this is going to be the concatenation of the two strings. Right? So if there is a string which is W equal to A1, A2 up till AN, and V is equal to B1, B2 up till BM, right? So then WV is the concatenation of these two strings is going to A1, A2 up till AN, B1 up till BM. So this is going to be the concatenation of these two strings. So given a string, now concatenation is one operation. So similarly, like we can also have another operation which is a reverse operation. So given a string W equal to A1, A2 up till AN, then the reverse of the string WR is obtained as AN up till A1. Right? So this is going to be the reverse operation. Similarly, like we can also find out the length of a string. Right? So the length of a string, say W, is denoted as the cardinality of W. Right? So this is going to be the number of symbols in the right. So now so far what have we done? We have defined something called as symbols, or maybe like we have defined something called as alphabets, right? So now from these alphabets we have defined strings, right? Then we have defined some of the operations on these strings. Then we have suddenly arrived at the length of the string. So now you can have a string of maybe length 1 or 2 or so on. You can also have a string of length 0, right? So if say if you have so a string of length 0 is denoted by the symbol lambda, or in some textbooks like you may have this symbol epsilon that denotes the string of length 0, right? So now we already know that lambda is going to denote the string of length 0. So if you have a string of length 0 and if you take the cardinality, then you're going to have the value 0, right? So now it means that, this basically means it's an empty string, right? So lambda means that it's an empty string. So it means the string with no symbol at all. Right? So it means that the string with no symbol. Right? So now, if you do a concatenation operation with this empty string, say given that you have a string W and you perform a concatenation operation on this string W, so you have lambda W, then you can get lambda W is going, you can concatenate a empty string, you can prefix an empty string with a string W, right? Is going to be equal to W is going to be equal to suffixing the empty string with the string W. So this is going to be holding for all W, right? So now similarly, like we can also define the substrings. So given a string W, we can we can we can say if this W is formed of two symbols, say W is equal to V and U, then V V is a substring of W and U is a substring of W, right? So if given a string W with a name W, and if this string is made up of two symbols, V and U, then V is a substring and U is a substring, right? Now, we can say that V is a prefix of W, and U can be said to be a suffix of W. So now, given a string which is say W equal to ABV-IIITM, then we can say that um, uh, lambda A, AB, ABB, ABBA, and ABB-IIIB, all of these are say prefixes of W, right? So uh, we may be able to say this one. Right? So similarly, like we may be able to say that ABB-IIIB, A BB-IIIB, BAB-AB, B lambda. All of these are suffixes of W. Okay, so we may be able to say this. Now, if you look at the length of the concatenations, say for instance, if you have a string, we saw that given string, we will be, I mean, given two strings, we will be able to concatenate them. Right? So what is going to be the length of the concatenation? The length of these concatenations is going to be, so it means we need to find out what is WV, and this is going to be the sum of W plus, I mean, the cardinality of W plus the cardinality of V. Right? So now, now we can also find out, I mean, find out, we can repeat a particular string. Say, so far, like we saw W concatenation with V. Right? Now, we may also repeat a particular string. Right? So, we can repeat a string twice, we can repeat a string thrice, and so on. Right? So now, if W is a string, then W power n, it stands for the strings that are obtained by repeating W n times. So W power n is the string. I mean, this is going to denote the set of strings that are obtained uh, by repeating W n times. So say if you have an alphabet which is sigma equal to a comma b, and the set of strings, or you may have the set of all strings from this alphabet, which is going to be maybe lambda. Then you're going to have A, B, AA, AB, BA, BB, and so on. Right? So this is going to be an infinite set, right? So this is going to be the set of all strings this alphabet, right? So now let's assume like I have a language. So a language is going to be a subset of this particular set, right? So language is going to be a subset of this particular set. Say, for instance, I may have a language where I have W such that the length of the cardinality of W is equal to 2, right? So in that case, like I'm going to have this language L1 that is going to be having strings which are AA, AB, BA, and BB, right? So this, like, I can have n number of definitions on this particular set of strings. Right? So this each of these definitions is going to give me a different set of strings that form part of a language, right? So so that's how, like, I'm going to define a language from an alphabet. So I have an alphabet. So from the alphabet, I have strings, right? Strings are formed from the using the symbols of alphabet. From the strings, like I get the I define the language, right? So now now we are looking at this thing where we are saying like we will be able to repeat and we will be able to get some strings. Right? So if W is a string, right? So if you have a string W, then W power n is string that is obtained by repeating W n times. So it's the string obtained by repeating Wn times. Right? So you repeat Wn times, you get a string that is W power n. So if W is a string, say for instance, you have W equal to AB, right? What is then W power 0? So W power 0 is going to be a lambda, right? So by so you get a string of length 0. So lambda always means a string of length 0, right? So this needs to be kept in mind, right? Lambda means a string of length 0. It doesn't mean that it is not a string. Lambda is a string, but it's a string of length 0. Okay, so by repeating W0 times, what you get is a string of length 0. And this is true for all W. Right? For all W, you are going to get W power 0 is equal to lambda. Right? Then similarly, like if sigma is so sigma, we know that sigma is going to denote alphabet. Right? So if sigma is an alphabet, then sigma power star is going to denote all the strings. So it's going to denote the set of strings obtained by concatenating 0 or more symbols from sigma. So I have sigma as an alphabet. Then sigma star is going to denote the set of strings obtained by concatenating 0 or more symbols from sigma. So this set, I mean, which I told you here, the set of all strings from this alphabet, this can be denoted by sigma star, because this is, first of all, this is going to be an infinite set. So it's going to give you the set of all the strings that are obtained by concatenating 0 or more symbols from sigma, right? So it also means that sigma star, so it contains zero or more symbols, right? So concatenating zero or more symbols, right? I concatenate zero symbol. It means it contains the string of length zero also, right? So sigma star always contains lambda. Now we can have, if you want the set of strings that do not contain lambda, then you obtain it by sigma, sigma, you write it as sigma plus, right? So sigma star is going to contain lambda. Sigma plus is the set of strings obtained by concatenating one or more symbols from sigma. So you can write this as set of strings obtained by concatenating one or more symbols of it. So, so, so it's going to be sigma star minus lambda. Right? So now this is a set, right? So lambda doesn't mean, or it doesn't mean it's a empty set, right? So empty set and lambda are not the same, right? So here you have a set with one string, and that string is a string of length zero, right? Empty set you denote by this phi, and this and lambda are not the same, right? So it doesn't mean that lambda and empty set are the same, because you can always have a set with lambda symbol, and this is a non-empty set, right? So now, um, so one more thing is that sigma star and sigma plus, right? These both are infinite sets, right? So why they are infinite sets? Because there's no limit on the length of the strings on this set, right? So because due to no limit on length of the strings, right? So both these are infinite sets. So in general, like general, we say language as is a subset of sigma star, right? The language is a subset of sigma star. Okay, so that's why we say that a language, as I told you, here I defined a language which is L1. L1 is defined as a subset of this language is a subset of this sigma star. So now um, So, so any set of strings, any set of strings on an alphabet sigma can be considered the level. So now our goal is to is first of all to define specific languages, and for to make the computer to identify strings of the specific languages, right? So our goal, first of all, I want to define a specific language, right? So I want to be able to define a specific language. So I told you like we started with alphabet, then we came to language, right? Now thing can be any subset of this set of strings can be a language, right? Now this is set of all strings, right? So you have language, right? Now I should be able to define languages, right? So why do I want to define languages? So that I am able to uh, uh, make the computer to identify strings of a specific language, right? So that is the ultimate goal. So and who is that? Can you please mute your mic? You can define the complement of a language. Right? So, given that you have, who is that? I mean, can you please mute your mic? So, now we'll look at one more definition, which is called the sentence. So, I mean, the formal term for a string in a language is called a sentence. So, you can say it as a string, also a sentence. A string in language L is called a sentence of L. So a string in a sentence in a language L is called as a sentence in L, right? So so you have alphabets, right? So then you have strings, and then you call them as sentence. So uh, now we look at complement. So we know that the languages are basically sets, right? So since language is a set, so you are going to have a language, going to have a set of strings or sentences. Then if you have two languages, then you will be able to perform some operations on these two languages, and you can get a third language, right? So you may be able to perform a union or intersection or difference, and you'll be able to, because both of these are sets. So all the set operations can be used to define the third language. So similarly, like we may be also able to define the complement, right? So if you have a language L, so if there is a language L, then the complement of this language L bar is defined by the set of all strings. What is the set of all strings? The set of all strings is defined by sigma star minus L, right? So this is going to be the complement of this particular language, right? So now similarly, like given a language, so earlier like we were not talking in terms of language, right? So now we are looking in terms of language, right? So here looked at a single word, right? So single string, and then we looked at how we can reverse a string and so on. Right now we look at language. So given a language L, given a language L, then the complement L bar is obtained in this fashion. The reverse of a language L power R is obtained in this fashion. So here the reverse of this language is going to have all the strings of that language reversed, right? So, uh, uh, so what is going to be my language? My language is going to be a set of strings, right? So it can be, it can include, so it's going to be a subset of sigma star, right? So now, this is going to be a subset of sigma star, right? So mm, mm, now, uh, uh, now since we have this as the language, then we will be able to reverse a language. So the reverse of a language, L power R, is going to have all the strings of the language in reverse. So that then you call it as the reverse of the. Now, if you have two languages, L1 and L2, then the concatenation of these things or these languages are obtained as L1, L2, maybe like then the 3 is equal to L1 followed by L2, such that it's going to have X followed by Y. Right? So where X belongs to L1 and Y belongs to L2. Right? So in the concatenation operation, first you are going to have the strings of L1. Right? So if string L1 is going to have 1, 2, and L2 is going to have 3, 4, then your string, the language L3 is going to contain a concatenation of L1, L2. So it means that 1, 3, 1, 4, 2, 3, 2, 4. Right? So this is going to be after concatenating L1 and L2. Um, Now, in this way, like if you can also concatenate, say, L4 can be L1, L1. So, so, so we just were looking at the concatenation. Okay? So we can have a language which is concatenated with itself also. So We can write in that case the concatenation as say L power L4 or L. This can also be written as L1, 2. So this is going to be L1, L1. So we can define L power n as L concatenated with itself n times. So now what's going to be L power 0? L power 0 is going to be uh, um, lambda. Right? So now similarly, what is L power 1? L power 1 is going to be L is a language, then L power 0 is going to be lambda, and L power 1 is going to be L for every language. So now you also define something called as a star closure of language. Right? So what is meant by star closure of a language? So if L is a language, right, then L power star, right? So we just defined L power 0, L power 1, and we also defined L power n. Then L power star is going to be equal to L power 0 union L power 1 union L power 2, and so on, right? So like we defined sigma star. Right? So earlier we defined sigma star. Sigma star is going to have a set of strings obtained by concatenating zero or more symbols from sigma. Right? So similarly, like now we use it to define the star closure of a language. So star closure of a language is going to have a concatenation of symbols from sigma whose length of the strings may be 1, 2, and so on. Right? So this can be defined in this form. So if L is a language, then L power star is going to have strings of length 0. Then it's going to have all the strings of, from the language. Then strings concatenated, strings of this language concatenated twice, right, and so on. This mm, uh, this is going to denote the times, number of times, like you're going to concatenate the string of the language. Right? If you're going to have L is equal to say AB, BA, then you're going to have L power 0 is going to be 0. Then you're going to have L is going to be AB and BA. Then L power 2 is going to be AB, BA. Right? Then BA, AB, maybe then AB, AB, right? Then you're also going to have BA, BA. So and so on, right? So it's going to have this kind of thing. So so this is all going to be part of this L power. Is going to be a infinite. So now you also define another thing called as the positive closure. Right? So the positive closure of a language that is defined as L plus. Right? So just like we had sigma plus, so in L plus you don't have um, no, you don't have, it's going to be L star minus L power 0. So you don't have L power 0. So you have L plus is going to be L1 union L1 union L2 and so on. So it's going to be of this order. Now we define, okay, so I mean, this is just an introduction of the languages. So we will define another thing which is called as the second part, which is grammar. Right? What are grammars? So I told you, like languages are going to say. Um, grammar basically, like if you want to study any particular language, you need to have a way to define a language. Right? So the definition of the language is what is given by a grammar. Right? So if you want to study a language mathematically, to study a language mathematically, you require that you should be able to define, or you should be able to describe language. We need a mechanism to describe a language, right? So now it's basically, the grammar is basically a language definition mechanism. So, so grammar is basically a language definition mechanism. So this is true with respect to our spoken languages, and the same is true with computer languages also, right? So true with spoken languages, and true also with computer languages also. Right? So now basically, like what this grammar does. Grammar provides order to the words. Right? So you have words. Now, what should be the order in which the words should be placed, right? So, so that these words together form sentences. So, sentences of the so uh, so that is the main goal of grammar in a natural in a spoken language. So for instance, like if you have a sentence, then the sentence should have maybe a noun phrase followed by a predicate. Right? So if you look at a noun phrase, then you have an article followed by a noun. Then if you look at a predicate, the predicate consists of verb. So now, if you have, so if you look at article, then you may have, in an article, you may have the words like the, a, and so. In a noun, you have words like cat, uh, dog, and so in verb, you have words like run. So now I'll be able to, if I have a word, a dog, walk. So if I have a sentence like this, then using this construct, I will be able to say that this is basically an article by a noun followed by a verb. And further, I will be able to say that this article and noun together forms a noun phrase followed by this verb is the predicate. Right? Now, further, I may be able to say that this sentence. So, this kind of a thing is called as derivation. I mean, this is true with respect to uh, 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 grammar, computer language. So I will be able to say, given a sentence, I mean, given the definition of a sentence, I may be able to arrive at top down from a sentence to a valid sentence also, or given a set of words, I may be able to say whether it's able to derive a sentence. Say, for instance, if I have a sentence, A walks dog, right? So if I have a sentence like this, then I will not be able to derive this sentence from this sequence of words, right? The order of these words are incorrect, that I will not be able to derive this root of this derivation, which is sentence, right? Since I am not able to derive this, say that this sentence is wrong. So the idea is the same. Similar idea is what to be used in order to define the sentences in the language. In order to define this, you have, I mean, formally, in order to define a grammar. So grammar in the subject is going to be given by a quadruple, right? So grammar is given by a quadruple, right? It basically means that there are four tuples, right? So you're having G is equal to G is the grammar. This is given by V, T, S, and P, right? So grammar consists of these four uh, uh, tuples, right? So now this grammar. So this is basically a language definition mechanism. Okay, so this keep in mind, right? Grammars are language definition mechanism. So now we have this quadruple, and in this quadruple we have V. V is a finite set of objects called variable. T is a finite set of objects called terminal symbol. S belongs to V is called as a special is a special symbol called dot symbol, and P is a finite set of directions. So maybe I think I will discuss more about this in tomorrow. So if you have any doubts, you can just so any queries? Okay, I'll just unmute them. We can unmute and ask. can unmute and ask if you have any queries. Okay, thank you. Yeah.